What does it look like to ascend from Earth to space at the speed of light? If you decided to ascend to space at the speed of light, about 300,000 kilometers per second, you'd experience something truly extraordinary. Since the speed of light is faster than anything we can imagine, this journey through the atmosphere and into space would be unlike anything we could possibly perceive. In this video, we'll explain how it would feel as you move through each layer of the atmosphere, one after another, until you reach space. Stage 1. Ascending from Earth's surface. The troposphere. Location. This layer starts at the surface of the Earth and extends up to about 8 to 15 km. What happens when you start ascending at the speed of light? As soon as you start your ascent, you would feel an incredible acceleration. The air around you would rush past at a mind-boggling speed, but since you are moving faster than sound, and many times faster than any aircraft, you wouldn't feel any air resistance or sudden weather changes. Within seconds, you would pass through the troposphere, where all weather phenomena, like clouds, rainstorms, occur. The blue sky would gradually start to change as you ascend. Stage 2. Passing through the stratosphere. Location. From around 15 kilometers to 50 kilometers above the Earth's surface. What happens as you pass through this layer? By this point, you would be approaching the ozone layer, which protects Earth from harmful ultraviolet radiation. The ozone layer absorbs UV rays from the sun. Although you're traveling at the speed of light, you would be shielded from harmful radiation due to this protective layer. As you ascend, the sky would gradually transition from blue to dark, and the atmosphere around you would begin to thin. Stage 3. Moving into the mesosphere. Location. From 50 kilometers to 85 km above the Earth's surface. What happens here? In this layer, the temperatures drop to their lowest, reaching around 90 degrees Celsius at its peak. With your light speed velocity, you would pass through this layer in the blink of an eye. The extreme temperatures wouldn't affect you because of your incredible speed. If there were any meteors approaching Earth, they would burn up in this layer, protecting the surface from incoming objects. Stage 4. Reaching the thermosphere. Location. From 85 kilometers to 500 kilometers or more above the Earth's surface. What happens here? As you pass through this layer, you would experience an immense rise in temperature, reaching up to 1,500 T-Watt or more. However, due to your speed, the extreme heat wouldn't have any effect on you because you're moving too fast for it to impact your body. This is the layer where phenomena like auroras, polar lights, occur as charged particles interact with Earth's magnetic field. As you move through this layer, you would witness the auroras dancing around you in spectacular colors. Stage 5. Entering the exosphere. Location. From 500 kilometers to around 10,000 kilometers above Earth's surface. What happens here? By now, the atmosphere has become so thin that individual gas molecules can escape into space. At light speed, you'd essentially be entering the realm of outer space. The sky would turn completely black, and you'd be almost at the edge of the Earth's atmosphere. This is the point where you would be very close to where satellites orbit in space. Journey into outer space. The moment you cross the exosphere. After this rapid journey, you'd find yourself in true outer space. Earth would appear as a tiny dot in the distance, just like in images from satellites. You wouldn't notice the passage of time, nor would you feel any air resistance because you're now in space, where there is no air. Light would interact with the surroundings in strange ways, and Earth would feel distant, though you'd still feel as if you were moving incredibly fast. How this affects time and space. When traveling at the speed of light, time would appear to slow down relative to the rest of the universe, according to Einstein's theory of relativity. This means that if you were able to observe time, you might see events around you happening either much faster or much slower compared to your perception. If you decided to ascend to space at the speed of light, you'd witness the world in a completely new way. You'd pass through each atmospheric layer, from the troposphere to the exosphere, with each one offering a unique experience. With light speed travel, you would surpass everything in the blink of an eye. This journey would be unlike any other, allowing you to experience time, space, and physics in ways that are almost impossible to imagine. 1. Traveling at the speed of light. What is the speed of light? The speed of light in a vacuum is 300,000 kilometers per second, 282 miles per second. This means that light can travel around the Earth 7.5 times in 1 second. It's faster than anything we can imagine, and faster than any object or vehicle we can currently build. How does traveling at the speed of light affect time? Einstein's theory of special relativity states that the closer you get to the speed of light, the slower time appears to move relative to an observer watching you. This means that when you travel at the speed of light, time stops for you. For example, if you were traveling at light speed, you wouldn't feel time passing. But for the people watching you from Earth, it would seem like you reached space in the blink of an eye. Can we travel at the speed of light? Currently, no material object can travel at the speed of light. According to the theory of relativity, any object with mass would require infinite energy to reach light speed, which is not possible with our current technology. However, time travel, in some theoretical cases, could occur at these speeds. Effects of light speed travel on the atmosphere. When you start ascending, the layers of the atmosphere that you pass through differ greatly from one another. At light speed, your journey would be so extremely fast that you wouldn't have time to notice many environmental changes. You would pass through each atmospheric layer in mere moments. Troposphere, where all weather phenomena occur. If you were traveling at light speed, you wouldn't feel the weather changing, and the clouds would disappear in an instant. Stratosphere. With the ozone layer protecting the Earth from ultraviolet radiation, it would be impossible for you to feel any harmful effects as you pass through it. Mesosphere. Meteors would burn up in this layer much faster than we could notice. Thermosphere. Temperatures would rise dramatically here, but since you're moving at light speed, the extreme temperatures wouldn't affect you. Exosphere. When you reach this layer, which is essentially the edge of outer space, the sky would become completely dark as the air becomes very thin. Physical effects on the human body. Although the human body wouldn't feel many effects at such incredible speed, in reality, if light speed travel were possible, humans couldn't survive under these conditions due to extreme radiation, lack of oxygen, and extreme heat or cold. Even if the journey were possible, the technologies required for survival would be colossal and beyond our current capabilities. 3. Time travel effects. Theory of special relativity. According to Einstein's theory of special relativity, if you travel at speeds close to the speed of light, time would start to stretch out or slow down for you compared to the rest of the universe. In other words, while you wouldn't notice time passing, the world around you would seem to move faster. We've reached the end of our journey through the atmosphere to space at the speed of light. While light speed travel is still far from reality, understanding this concept opens up new horizons for exploring the universe. If you enjoyed the video, don't forget to subscribe and leave your questions in the comments. See you in the next video.